Hi everybody, this video is about vector fields. So a vector field can be thought of as a function which assigns a vector to every point in its domain. So for instance, we could think about a function that takes every point in the plane in 2D space and gives it a 2D vector. Or we could think about a function which takes every point in 3D space and assigns it a three-dimensional vector. There are any number of other examples, possible combinations and ways to do this, but these are ones that we'll probably deal with the most. So here's an example, a specific example of a two-dimensional vector field. Take a moment and pause and see if you can come up with what you think this vector field might look like. What might be going on with this particular vector field? And maybe you thought it would be something like this. So again, at every point in space, we've assigned some vector. At every point in the plane, every point x, y, we've assigned some vector. We can't show all of them, but we can show sort of a selection of those vectors to give some sense of what's going on with the field. And you should, if this wasn't exactly what you expected, you should definitely pause again and make some sense of it. I'll point some things out. So for instance, when the x-coordinate in space, so places where x is 0, that means that the y-coordinate of all those vectors is going to be 0. And if you look along the line, the vertical line where x equals 0, you'll see that none of those vectors have any y component. Similarly, if you look in space where points have a y-coordinate of 0, that anywhere where y is 0, so along that horizontal line, the x component of the vectors that in this vector field are going to be 0, and you can see that. So again, pause and take a moment and just sort of look at some spots and points in the plane here and make sure you understand that the picture matches the vector field. One thing you might notice is that the magnitudes seem a bit off. So for instance, at the point 1, 1, we would expect a vector with an x component of 1/2 and a y component of negative 1/2. And if you look near that point, that's clearly not the magnitude. The magnitude of that vector just doesn't match up. So commonly when we're visually representing vector fields, we'll scale all the magnitudes of the vectors back so that things are visible. If we had all these vectors at their full magnitudes, things get a little busy, this gets a little crazy. It's hard to tell what's going on. So when we're looking at visualizing a vector field, we'll represent some small selection of points to kind of give a feel of what's going on with the vector field, and we'll probably typically also scale those magnitudes back so that we can tell what's going on and it doesn't just become a big jumbled mess. We can look at vector fields in 3 dimensions as well. Some examples are fairly nice, but in general it's a lot harder to sort of see what's going on. Things get pretty busy pretty quickly, but I think you get a sense of what's going on from the 2D example. All right, and then we've seen vector fields before, but we didn't have that name. What do you think we might have seen before that was a vector field? Well, the gradient. The gradient's a vector field. So remember that the gradient takes some multivariable function, and so for each input point of that function, the gradient gives us a vector, and specifically it gives us the vector that points in the direction of greatest increase of the value of the function, which is a particularly nice vector field. But this is a vector field. You tell it a point in space, and it tells you a vector associated with that point in space. So that's the basics of vector fields. We will talk about this more in class, and I'll see you then.